In my last video, I did a demo of the hover functionality. That's where you can, on the toolbar now in DataGraph 5.1, you can turn the hover on. And when you do, when you move your mouse over different types of graphs, you get these pop-ups that appear. One of the examples I showed you was this one here with using a function that shows you the mins, the maxes, various critical points, as well as intersections between functions. So one of the other things that we did in DataGraph 5.1 is we did an upgrade to the function command itself and gave it the ability to allow you to more easily explore functions and the coefficients that are in them. So that's what I'm going to show you how to do in this video. Let's start with a simple example. I'm going to make a new graph and add a function command. We can do this by clicking draw in the toolbar. You'll see the function command down here that we can click to add, and then it adds that object. So to plot a function, I just need to go ahead and type in what I want to plot. I'll do sine of x here. And notice that there's also a range that by default is always going to be 0 to 1. I'll go ahead and set this now to negative 10 to 10. Okay, so here's my function. Let's maybe give it a more interesting color and a little thickness. Make sure you can see this here. So what I want to show you is what happens now when I add coefficients into this function, unknowns that are not defined, where in the past you would always have to define a global variable when you had unknowns in an equation. But here, for example, what if I do, and actually before I do this, let me expand out the command so that you can see this. And I'm going to do a times, hit return. Notice what just happened. Now there's an a variable down here. It's set to 1 by default, so it didn't change anything we see. But now let's do plus b. Now that did change the scale because b is, it's not being multiplied by b. We just added b, and it did change the output of the function. And if I move these around, you can see it's changing the values. Now, to make this a little clearer, I think it's easier to fix the range. So let's go ahead and have the range of our y-axis include a couple of numbers that are always going to be there. So you can do this by expanding the axis settings. There's an include in y option here. But instead, an easier way to do this is you can double click right on the axis, and I'm going to include, let's say, -2 to 2. So the axis range will always include those two numbers no matter what I'm actually drawing in my commands. Now when I change my a value, you can see a lot clearer, I think, what is going on here. And also the same for the b. So b is just moving my sine wave up and down. A is changing the height of my wave. In the prior versions of DataGraph, what you'd have to do to plot a function like this, that you had coefficients that were not defined, you would have to add a global variable in order to be able to have that be drawn. So I want to show you what happens here when we add global variables. We do that over here on in this section of the user interface. So the variables that have been created here are what we would call a local variable. If you've never heard that terminology before, this is kind of a coding type of terminology. A and B are only known within the context of this function command, but I can create a slider, for example, and I can call it A, and let's see what happens when I do that. Well, notice now I no longer have this local variable a because a in the global space over here takes precedent over an a locally. So what the program will do when you add a function, it's first going to check to see, is there a global variable that has that name? And if so, it will use that. And if not, like for b in this case, b still is defined only here locally. Since there isn't a global variable for it, it's going to go ahead and continue to have a local setting that I can use to change that value. The next thing I want to show you is how I not only can change the value of my parameters here, but I can also change the functions themselves. And we're going to use the function library to do that. But first, I want to show you what happens if I go ahead and delete this global variable a. So if I just highlight this variable and hit the delete key, notice that it comes back into my list of local variables and it remembers the value that it had from before. So it will have that memory of what the last value was within the local context, and you'll still have that so you don't lose it. Okay, next thing, let's go ahead actually and clone the graph that we're currently working with. And now in this copy is where I want to swap out this function and show you what happens. And I'm actually going to use functions that I have within my function library. If you've never used this before, this is a custom library that you can set up. And you go under the DataGraph menu, go to Settings, and which is different in 5.1. It used to be Preferences. In any case, I have two functions that I've added here, a sigmoid function and a Gaussian function. And to use those within the context of my function command, I click the gear menu on the right of my object. You'll see an option for function library, and let's go ahead and click sigmoid. Now, for this example, I don't actually need this to go from 2 to -2 like I did in the last one. So if you double click here on the axis again, and I can just delete where I had -2 as one of the entries, and now I'll have this going down to 0, which is where I want it. But what happened when I did add this function, which is a function that has an A, a B, and a C? Well, I have here an A, a B, and a C. So again, adding them all in the local context. And if I change these values, then I'm going to see their impact. So A here changes the height of my sigmoid curve. B is going to change the location of where the curve is. Again, with these sliders, if you make the value much bigger, I had it on a very small number, so it was giving me a lot of fine control. But now moving it up to a larger value, now I have a lot more mobility that I can show here in the range that I have. C actually will add in essentially diffusion into this curve, so it will flatten it out a lot more. Or if I bring C close to 0, I get a much sharper boundary between the lower and upper parts of my curve. Okay, but again, I wanted to show you what happens now when I change this. So notice I have my values here for A, B, and C, and I'm going to pick a different function now. So I can change this to a Gaussian function, which I had already set up, and also have an A, B, and C. Actually, you can see here how the tooltip will pop up for each of these if you hover the mouse long enough. So you can see the Gaussian function. When I click that, the values for A, B, and C don't change. They'll still be there. And again, I can explore what they do. A here also makes my my Gaussian peak higher. B is going to change the location of my peak. And C, if you want to see what that does, it adds more, again, diffusion is how I think of it. It's going to be a much wider peak when I change the value for C. One of the things I've had to do for some of my own research is to plot the same function with different variables to, again, show what the impact is of different coefficients and a different range of values. So one of the things that you can do here with this function command, you can do that here, and I think it's a lot easier now that we have these local variables set up. So I'm going to show you two different ways that I had thought would be useful to illustrate this. So say, for example, in this function, I wanted to have A is equal to 1, B is equal to 1. Actually, maybe I'll do B is equal to 0, so it'll be centered in the middle, and C is equal to 1. And in my legend, instead of showing the function, which it does here by default, I could just type in A is equal to 1, B is equal to 0, and C is equal to 1. For now, we don't have a dynamic way to connect those. Oh, wait, and what did I say? I said 0. There we go. So you need to make sure that you've got that right. But then if you want to have a second function, I can just take the one that I created, copy and paste this, or my favorite option, hold the Option key and drag it to make a clone. We'll go ahead and change the color for this and maybe even make this a dashed line, and then change the value for C, for example, to 2, and we could do the same thing for A, and then just go ahead here and change A is equal to 2 and C is equal to 2. So you could see how you could build a series of these where you have several of these functions, all with different values and with the values that are documented on your graph. So the other way that I wanted to show you is actually combining having the local variables set up, but using global variables to set them. So let's go ahead actually and clone this graph. And I'm going to, just to make this more interesting, we'll change this to the sigmoid. Again, actually, I selected that, but you don't have to. And I can, now that I've actually set one of them, I can just copy this and paste it in. So now I have my sigmoid, but I'm going to do this actually using global variables that are combining with what I have here. So I'm going to make 3 slider variables, 1, 2, 3, and I'm going to call this A1. So I'm not going to call it the same name as what it is in my actual function. Actually A1, B1, and C1. There we go. And I can, set the ranges for these individually, but here, just to get this set up, we'll put those, give those something other than 0. And I'm going to, within here, have my local variables set to these global values. Oh, not C2. Oops. Well, actually, this is good to illustrate. What happens when the variable's not there? You're going to get red, indicating an error. So I can change this to C1. Now I see everything's calculated properly. This is going to be different than, I'm actually not going to use the hard-coded values. I can use tokens for each of these. So this would be now dynamic. Oops. And here's the last one, plus to add C1. There we go. So now, let's see, move that there. And I think I'll move this to the upper left so we can see that better. So now the first one, the green one, is set up. So it changes as I change my sliders here. And I can do the same for the second one. Or what I usually do, again, is we'll just clone the one that I set up the way I want. I'm going to do 2 more of these in different colors, and again, different line styles as well. So we can have 3 different line styles. Now they're still all the same values, but I can actually go into my local variable that's set up here. And for example, if I want to change the value for C, I can use an expression here. So now this is going to be C times 2. And my last one, I'll have C times 4. And let's see, maybe 2. We don't need this to go up to 2. We'll just have it be the range that these functions are showing. And so again, this is now a way that I can show these. But what am I missing? I'm still missing the legend is still not right here. So if you want to change the legend properly, you can have functions also within the tokens themselves. So actually the green one does not need anything. The token here, I'm multiplying C1 times 2. So I can click on the token, select use function. And now I just, I'm going to multiply that by 2. And you'll see how that updates here within my legend. And we'll do the same thing. Oops. This one where I'm multiplying it by 4, use function, x times 4. And now, so that took a little bit of setup to get the legend to take into account what I'm changing here, but you can see how the legend is dynamic, my values are dynamic, and they're all changing. Actually, I guess it helps maybe to keep that going up to 2 for varying A. And I can change my range of A to go up here to 2. So now you can actually see that changing in a meaningful way. And all of these, if I want to pin it back to one specific number, I can change this again here, and make my C value A1. Of course, then maybe I'm doing this a lot of times, so you're going to really hopefully remember that double click shortcut. Anyway, I really hope that this was helpful for you and gives you some ideas on how you can use this new functionality within the function command to plot graphs like the ones I showed you today.